Hi class, today we're going to talk about graphs of functions, which is section 1.2 part 1. Our objectives are to find the domains and ranges of functions, to use the vertical line test for functions, to determine intervals on which functions are increasing or decreasing, and to determine relative maximum and minimum values of functions. The graph of a function f is the collection of ordered pairs f of x, such that x is the domain of f. Notice here we are kind of used to seeing this as xy, but that then just lets you know that y is the same thing as f of x. So that's kind of where that comes from. All right, so in example 1, it says use the graph of the function f to find a, the domain of f, and b, f of -1. So the domain we're going to focus on first. It's kind of already shown to you in this picture. But our domain, remember, domain goes from left to right. So your furthest left point to your farthest right point. So the domain, so if we answer question A, domain, it's already showing you here that domain, the furthest left that it's going to hit is -1. The furthest right is going to hit is 4. Okay? But with that being said, we have to focus on the endpoints. Are we going to include these numbers or are we not going to include them? If the point is closed, then that means that we do include it. It is actually sitting on that point. If it's open, it's all the way up until that point, so we cannot include it. So our domain for this one, depending on which notation we're going to use, let's use interval notation first because it's a little bit easier to talk about. It would be from using a bracket, -1 up to 4, parentheses. Brackets mean closed dots, parentheses mean open. If I use set notation, which again is just another way of saying it, this is again interval notation. Set notation would be domain is x such that -1 is less than or equal to x is less than 4. Less than or equal to -1 because it includes the -1, and less than 4 because it does not include 4. And again, we usually enclose it within braces. And again, this is set notation. So whichever one you feel more comfortable using, typically people like to use the interval notation. It doesn't matter to me. Just understand that if you ever see 2 sets of parentheses on interval notation, it is not an ordered pair. It is still technically interval notation. All right, the second part, B, it says f of -1. So what they want to know is what is the output value when x is -1. So what is the output value when x is -1? So let's go to where x is -1. Okay, x is -1 right on this line. Okay, so what is our output value here? So that means I need to know what is my y value. My y value when x is when x is -1, it looks like it's about -5. Yeah, and it even kind of tells us right here with the ordered pair. Okay, so when x is -1, your output is -5, even though visually, like looking at the tick marks, it doesn't it almost doesn't seem so, but notice how it's counted. It goes all the way up to -8. So anyways, the function at -1, or the output at -1, is -5. And that's it. This may still seem a little confusing, so let's take a look at the try to continue to answer. So here, again, it's the same function. It's asking what is the output when the input is 2? So what is the y, if you want to call it that, when the x is 2? So we go to our function, which is right about here when it's 2. What is our output? What is our y value? It looks like it's 4. So to answer our C, f of 2, so the output at 2 is 4. All right, the next one, range. What is our range? Well, remember, range measures how high and low your function goes. It tells you right here how high and low your function goes. So it looks like if I were to box it in, it goes from here to here. So, and at those points, they are both included. They are both included points. They are closed dots. So I would say that our range for D, it's up to you. We can use interval or set. I'm going to use interval first. And you always say from least to greatest. So for us, it would be from -1 to, excuse me, that is not -1. It's -5. -5 because that's the y value. So -5 up to 4. Again, this is interval. If we want to use set notation would say y. Y such that y is less than or equal to, or -5 is less than or equal to y, which is less than or equal to 4. Again, you always put your lower number first. And again, this is set notation. All right, let's keep going. So more information about our graphs. So the use of dots, open or close, at the extreme left and right points of a graph indicates the graph does not extend beyond those points. So if no dots are shown, we assume that it's continuous. So we assume that we see arrows, in other words. So in example 2, we're going to find the domain and range of a function. As I mentioned in a previous lesson, square root functions, the fact that it does not tell us whether if we see plus or minus, that lets us know that it must just be the positive form of that function. And as a reminder with transformations, if it's -4 and it's under the radical sign, then it means it moves to the right 4 places. So 1, 2, 3, 4 to the right, and like that. So if I want to talk about the domain for this function, remember, domain measures how far left and right a function goes, right? Well, for us, where does it start? It looks like it's going to start at 4. It's going to start at 4, and then it's going to continue on forever into positive infinity, right? So depending on how you want to write this, our domain it includes 4 to positive infinity, and you cannot bracket in infinity because infinity is continuous forever, so we have to leave it open. Or you can say x such that x is greater than or equal to 4. Again, it just depends on the notation you choose to use. All right, range. Remember, range is how high or low your function is. So where does it start? For us, it looks like it's going to start at 0. At 0, right? And as it lifts off, it's going to continue in the positive infinity direction. Okay? So what that means for us is in interval notation, it includes the value 0 because it's a point on that line. And again, where am I getting 4 and where am I getting 0 from? Because this part here is an ordered pair of 4, 0. Anyways, so it's from 0 to positive infinity. Or if I want to write it in set notation, it's y such that y is greater than or equal to 0. Perfect. Okay, I've actually already talked about the vertical line test because it's my preferred method of trying to figure out if something is a function or not. But either way, we'll go back over it. So it says, by the definition of a function, at most one y value corresponds to a given x value. So it follows then that a vertical line can intersect the graph of a function at most once. This leads to the vertical line test. And remember, if it intersects your vertical line more than once, then that makes it not a function. I know my graphs look really terrible, but we're just going to have to go with it. So it says, do the graphs represent y as a function of x? So in other words, another way of saying that is, are these lines functions? Are these lines functions? And according to the vertical line test, we can see with the first one that there is a vertical line right here. But we can obviously see that it's intersecting that vertical line in two places. So this one is not a function. Okay. On the next one, the second one, again, is making a vertical line, and it only crosses in one place. So this one is good to go. It is a function. So it is a function. This one here, I had to throw this in there just to kind of make sure that you understand. But this vertical line in this particular spot is not crossing anywhere. However, if I were to continue to make this move like left and right, like this vertical line move left and right, either way, it's not going to hit the graph in more than one place. So because it does not cross in more than one place, again, it is a function. So this one is a tricky one, and I just want to point out that gaps are okay. Gaps are okay. The main thing that, again, dictates whether it's going to be a function or not is whether it intersects the graph in more than one location. So again, this is a function. And in fact, this is a piecewise linear function. All right, let's keep going. So let's talk about increasing and decreasing. So it says, consider the graph shown. Moving from left to right, this graph falls or decreases from x equals -2 to x equals 0. It's constant from x equals 0 to x equals 2. And it rises or increases from x equals 2 to x equals 4. So we'll talk more, but essentially the main thing that you need to understand is we always read the graphs, always read a graph from left to right. So if I were a little, I don't know, if this were me, if I were a star, okay, and I'm traveling along this line, if I go down, I'm decreasing. If I go horizontal, I'm constant. If I go up as I'm traveling, then I'm increasing. Okay, and again, I'm saying I'm a little star, just kind of, so here I'm going down, I'm decreasing. Here it's the same, so it's constant. And here I am traveling up and I'm increasing. All right, so in this example, it says determine the open intervals on which each function is increasing, decreasing, or constant. Okay, so this one is a fairly large picture. I wonder if I can make it just a tad bit smaller. Well, now that we've got the directions, just know that we're trying to figure out what the intervals are. So I'm going to move this up so we have space. Okay, so on the first one, for the function f of x cubed, it is a continuous function, but it is continuously going. Again, if I mention that it has to go, we always read the graph from left to right. Remember, I'm down here initially, so if I'm down here initially, I am going up the entire time, so I am increasing. So this one is increasing, and I'm going to use interval notation if you don't mind, but I am increasing from -infinity to +infinity the entire time. Okay, let's separate this information so that we don't get confused when we start talking about the next one. Okay, on the next one, this one, again, I am traveling. I'm kind of doing some highs and lows on this one. So if I start here, I start by increasing. So I increase, I'm going to use shorthand, I am increasing from -infinity to -1. Everything always, by the way, describes the x value, right? Because if we're moving left to right, I'm specifically only focused on the x value. That's why I did not say -infinity to +2. Okay, so in other words, from way back here in -infinity up to this point, I was increasing. Okay, Then I began to decrease. My line started going down, right? So I decreased from -1 to +1. So again, from this point here to here, my graph was going down. And finally, we're on the up and up, and we increase again, this time from 1 to +infinity. So again, from here all the way outward, we are increasing. I hope that visual with that line helped, but anyways, that is increasing and decreasing in a nutshell. So here we're going to try this one. Technically this one is a piecewise function, but we should still be able to get the gist of it. So again, I am traveling. I started out lower, and it doesn't even matter if it's lower because it could be from here also, but that would still be decreasing, and I would still say that I'm coming from -infinity, because this side will always be -infinity and this side will always be +infinity. So I just want to describe that when we talk about intervals. Okay, so here we go. So I am coming from -infinity and I'm going up, so I'm increasing. So I'm increasing from -infinity to 0. So from here to here, I was traveling upward. Then I am constant, right? I am constant from 0 to 2. So anyways, from here to here, I remain the same. And then finally, I decreased because I started going down. I decreased from 2 to +infinity. And again, it doesn't matter that my picture or my graph is going downward. It's the fact that it's going to the right that makes it +infinity. So again, this section onward is actually decreasing. That feels probably very tricky, especially on the increasing and decreasing. But again, if we just remember that we're trying to stretch this line, it's almost like talking about domain, but not necessarily. But increasing and decreasing and where it's coming from and where it's going to, you just have to kind of focus on those areas. Okay, this is just vocabulary. So relative minimum, maximum. So the points at which a function changes its increasing, decreasing, or constant behavior are helpful in determining the relative maximum or relative minimum values of the function. So the graph shows you a couple of points like this. These two down here are considered relative minimums because they are the lower parts of your function. And then these two up here are considered relative maximums because they're the higher parts. What we're going to practice is in our calculators how to find these specific ordered pairs. So here we go. It says use a graphing calculator to approximate the relative minimum of the function f of x equals 3x squared minus 4x minus 2. Okay, so let's practice. In our graphing calculator, we're going to go to y equals, and we're going to type in our function. So where it says y equals, I'm going to type in 3x squared minus 4x and then minus 2. Just to give you an idea, if it were a standard window, which by the way, a standard window, the x-min would be -10, the y-min would be, or excuse me, the x-max would be +10, y-min is -10, and y-max is +10. If I use a standard window, this graph is going to look something like this. Okay? All right, so after that point, to find what I can tell, first of all, is that this is going to be a relative minimum, one, because the directions told me so, but the relative minimum is probably going to be somewhere around here. So to find that, what we do is in our calculator, we press the button second trace, and then we go down to minimum, which is number 3 in a TI-84. Okay, it's going to then ask us left bound. So you may see a cursor already blinking. What it's asking is place the cursor somewhere to the left of your minimum. So somewhere over here is good. Anywhere in that area where I kind of shaded blue, that's good. So mine is actually already blinking to the left, so I'm just going to press enter. Then it says right bound. So what it's asking now is for you to move your cursor somewhere where in the section where I have green. So now I'm going to move my cursor on the right side of my minimum point, and I'm going to press enter. Then it's asked for you to guess, so you just press enter again. And what I see as the minimum point is 0.67. I'm just going to round it up. 0.67 comma negative 3.33. And these are all repeating, by the way. If we know our fractions, we know that that's also the same thing as 2/3 comma negative 3 1/3. So that's the minimum, and that's how we find it. We're going to practice that again using the graphing calculator on our last example. Okay, so again, we're going to use a graphing calculator to find the relative minimum and the relative maximum. So this is a cubic function, so it is going to have like some hills and valleys type of thing going on. So again, go to your calculator, go to y equals. We're going to clear out our last function, and we're going to type in, use the negative button at the bottom of the calculator, not the minus button. So negative x, use the caret button, which is under the clear button on the right hand side. Type the number 3. And then move your cursor over because it may still be in the exponent section. And then you'll type plus x. And we're going to graph. Again, in a standard window. This kind of looks a little bit like this. Not the best sketch. But either way, what I can see is that I have a minimum here. And I have a maximum there. Okay, so we're going to find each one. So let's find the minimum first. So again, we press second trace, go down to number 3, which is minimum, and we are doing left bound and right bound of this point. So left bound of this point would be here, right bound would be right here. So we're going to move our cursor to the left of that point, and then move it to the right just slightly. And then we're going to guess, and that minimum that I get, or the relative minimum, as an ordered pair is approximately negative 0.58 comma negative 0.38. That's an 8. Okay, to do our next point, we would find the relative maximum because it's higher. So what was right on the other one is now left. So this section would be left and this would be right. So again, we just go to second trace. This time go to maximum, which is number 4. We're going to go just to the left of that point. Then we're going to go to the right of what we think is that point. And then so our relative maximum is 0.58 comma 0.38. And that is it for this section. Guys, if you have any questions specifically on example 5 and try 5 and how to find it in the calculator, we can practice that during some tutoring time. So please come see me if you have any questions.